9.3 says rank from smallest to largest first ionization energy. And the first series they give us is K, RB, NA, Li, and CS. So just to refresh your memory, the general trend is that ionization energy increases because within a given period, it's got the same number of shells, but then it's got more protons, so it's pulling in tighter, so then it's harder to pull off an electron. And then going down, so down a group like that, it's going to decrease just because these are bigger, these shells are going to be further away versus these shells up here are going to be closer to the proton. So as you go down, then it gets easier to pull off an electron. So with that in mind, if we look at what we're given here, that happens to be sort of going down this first column. So if you look at our periodic table, there's K, RB, NA, Li, and CS. So if we think about our trends, it decreases going down. So the easiest one to remove is CS. It's just going to follow this row. So Li, it's the hardest to remove an electron. So that's going to be the largest ionization energy. So you would do Li is the largest energy, and then just kind of put them in order that you found them. And then CS is going to be the easiest, so that's the smallest ionization energy. And that's going to be our first series. Second series in this problem is P, Na, Mg, Cl, and Ar. And if you notice on the periodic table, you can find them sort of all in a row. So P here, Na, Mg, Cl, and Ar. So if we kind of put it in the order we find them, we have Na, Mg, and then we've got P, Cl, and Ar. So recall the trend where going this way, it's harder to remove an electron because you're adding more protons and so they're pulling in tighter. So that means more ionization energy. So which one has the biggest ionization energy? That's going to be argon. And then going to the left, we'll just follow the trend of the periodic table. And Na is going to be the easiest because it has the least amount of protons. So it's not pulling as tight as the other ones. This third series here has ions, so we can't just look at the periodic table and kind of pull out the trends, and we're going to have to think about the protons and electrons individually. So CS plus, in terms of electrons, that's going to be 54 electrons. And then Ba2 plus, you'll notice, is also 54 electrons. And it turns out all of these have 54 electrons. So it's an isoelectronic series, but they do have different amounts of protons. So CS has 55 protons, Ba has 56, and then Te is going to be 52, La is going to be 57, and then I is 53. So even though they have the same amount of electrons, there are different amounts of protons. And whoever has the most protons pulls in those electrons tighter. Running out of room. All right, so if it's pulling in those electrons tighter, then that means it's harder to remove an electron, which means bigger ionization energy. So whoever has the most protons is going to have the biggest ionization energy. And we already said, well, the La3 plus, that has the most protons. And then if you just put them in order, the next best one is going to be that Ba2 plus, and then next best would be the Cs plus. Next best is going to be the I minus, and then lastly, the Te2 minus has the least amount of protons, so that's going to be the smallest IE, because it's the easiest to pull an electron off of that one. You'll notice it also kind of lines up in terms of charges. So another way you could think of it, which is also correct, is that things that are negative are already overloaded with extra electrons. So it's going to be easier to just start pulling away those extra electrons because they were just extra in the first place. Versus things that were positive, they already lost some electrons, so they're not going to want to lose even more. So that's a couple ways you can think about it. Usually for me, I usually just think about electrons and protons because you can't go wrong with that.